Kian has $400,000 from a court settlement to invest. Kian plans to invest the money into two accounts, one paying 3% simple interest and the other paying 4% simple interest. Kian would like to earn at least $14,300 per year to support himself while going back to college. How much should he invest in each account to earn at least $14,300 per year? All right, so we've seen problems that started sort of like this in the past. Let's call A the amount invested at 3%, and let's call B the amount invested at 4%. So we can invest $400,000. Now it never stipulates in here that we have to invest all of it. So what we can say is that the total investment, which would be A plus B, must be less than or equal to 400,000. We also know that Kian would like to earn at least $14,300 from the interest. It's simple interest per year, and so what we can write is then the interest, 0.03a, the interest from the first account, plus the interest from the second account, must be at least, and so that means greater than or equal to 14,300. All right, so let's do a little bit of work with this system. Let's also make the assumption that we must have positive, I should say non-negative values for A and B. We cannot invest a negative amount of money. All right, so first, let's work with the first equation, inequality, excuse me. And I'll draw that one in purple. All right, so if A plus B, let's think equals. A plus B equals $400,000. All right, well then it's easy to find the intercepts if we let either of the variables equal 0. The A intercept would be 400,000, comma 0, and the B intercept would be 0, 400,000. Right. And if we have 0.03a plus 0.04b is equal to 14,300, its A-intercept, letting b take the value 0, would be 14,300 divided by 0.03. 14,300 divided by 0.03. That's 47667, comma 0. And the B-intercept, letting A take the value 0, we would have 14,300 divided by 0.04, and that's 357,500. All right, so now let us graph this on its axes. All right, so looking at my scales, let's use a scale of 100,000 on each axis. So 1, 2, 3, 4, there's 500,000. On the A-axis, 1, 2, 3, 4, there's 500,000. On the B-axis. All right, our first inequality was A plus B is less than or equal to 400,000, and it had A-intercept of 400,000 and a B-intercept of 400,000, and I'll use a solid line to mark that boundary. Now, since A plus B must be less than 400,000, if I test the origin, 0 plus 0 is less than or equal to 400,000. That checks out, so I would shade below the purple line. All right, and in orange, for the second inequality, my A-intercept is roughly 480,000, so that's about here. And my B-intercept is roughly 350,000, so that would be about here. Again, using a solid line to mark that boundary. And let me again test the origin. Testing 0.03 times 0 plus 0.04 times 0. Is that greater than or equal to 14,300? Well, that's false. So I would not shade 0, 0 for the second inequality, and instead I would shade above it. So I need to shade the region that is below the purple curve and above, the purple line and above the orange line. And so I would shade this region, this wedge, there. So any point, any combination of A and B that satisfies that's within that shaded region would be a solution of the problem.